Hello, here are our notes over Station 7 in our polynomials unit. We are now doing something we call factoring with special products. There's two different types of special cases that we have, and you should have seen them when we were multiplying polynomials, that when we multiplied, there were some times that our middle two terms canceled out. And that happened when what was in the parentheses were the same except for one was a positive and one was a negative. And so then we were only left with the two terms. We were left with a binomial. And so that happens that now if I need to factor a binomial, how do I factor it? Because I can't use my X method. Well, you could, and I'll show you how actually, but there's a quicker and easier way. And this is really based on all your square roots. So knowing your perfect square roots, really kind of 1 through 100. So in this case then, if I'm looking at the first example, m squared minus 9, if I look at and I think about, okay, I'm going to have two sets of parentheses. And I need to know what goes in my parentheses. So my m squared, that tells me I'm going to put an m in front of, in the first part of the front parentheses for both problems. But then how about this minus 9? So what I'm really doing is I'm taking the square root, because if I look up here at the actual difference of two squareds, I started with b squared, but when I go to put it in my parentheses, it goes in as just b, which is the square root of b. So here in this case, the square root of 9 is just 3, and I would have a 3 here. Now, the difference of two squares then says one is positive and one is negative. Now I left a lot of room in there as I was typing these out, but here's then my answers. My answer would be x minus, or I'm sorry, in this case m minus 3, and m plus 3, and I'm done. That's factored. Now I just said I would also show you how you would do this using your X method. So if I try to do that X method from the last two stations, in this case my 1 times my negative 9, that AC value, my negative 9, would go in the top of my X. But when I go to look at my B value, I don't have a B value. And so my B value would be 0. And so now again, remember the whole idea with the X method is you're asking yourself what would you multiply together to give you negative 9 that would also add together to give you 0. And that's where the negative 3 and positive 3 would come from, because both of those, negative 3 times positive 3 gives me a negative 9, but negative 3 plus 3 gives you 0. So then you're going to divide both of these by your a value, which in this case is just a 1. So now I'm dividing both of these by 1. And I put the X with those ones so that then I can read my answer from the bottom up. Well, and I'll say, guys, a lot of times and on a test or quiz, if you put X's instead of M or whatever variable it is, I'm not going to count that wrong. And I'll even in Edulastic, I'll go back and give it to you if you have everything else right. We use X's so much, but if this would be an M because that's a variable we're dealing with. So my answer, again, reading bottom up, 1m minus 3 and 1m plus 3. So you can still do your X method, but if you notice, hey, wait a minute, these are perfect square roots. I can take the square root of both of these numbers evenly, and even including my variables. Okay, now the key thing is, again, is that that sign in between has to be subtraction. If it's addition, it cannot be done. So when I'm looking at this, to factor this, I would have in the first part the square root of 9 x squared again. Oops, is going to be 3. Square root of 9 is 3. So I'm going to have 3x and 3x from the x squared. And then my next number is 16y. So here, 16y squared, square root of 16 is 4. Y squared would be just y. So then here I'd have a 4y as well. And then I just have to determine my signs. In order to get a negative, I would need one of these to be positive, and I would need one of them to be negative. And there it's factored. So I think if you notice your positive and negative, I'm sorry, your square roots, the first and last number are perfect square roots, it makes it go really fast instead of having to do the X method. Take a minute and pause the video and try this third one on your own. hopefully you're back and you've tried it. So in this case, if I go to, again, do my parentheses, I'm going to have my two sets of parentheses here. Square root of 49x, square root of 49 is 7, so I'd have a 7x in both sets of my parentheses at the very beginning because it comes first. Square root of 81. So now I have my square root of 81. Square root of 81 is 9, so I'm going to have my 9. Two nines. And then how am I going to get a negative 81? One of these is going to be a positive, and one's going to be a negative, and there's my answer. So that's all there is to the first type of special factoring special type, and that's called the difference of two squareds. Difference of binomials, you could say. Okay, or it's a binomial. So here in this case, perfect square trinomials. Remember these that we had where we had a plus b squared, and I told you guys in order to multiply it, you had to write it out twice. We had to write that out as a plus b times a plus b. Well, in this case, when we're factoring, I really like, you can memorize these formulas, guys. You don't have to. This is another place that I would kind of rely back on your X, but in our answer, the way we write our final answer is going to be special, and that's what makes this a special. I'll be honest, if somebody asked me to write down these formulas to memorize, I'd have to really sit down and think about it. I can't just spout it off because I don't use the formulas. You can, if you're a person that does great memorization, you can memorize this a squared plus 2ab plus b squared, or the second one as well. Okay. But I think because the last two stations have really been focused on the X, hopefully by now you're comfortable with it. And so I would just do my X method here. I would have 1 times 16 or 16. Factors of 16 that give me the b value, which are 8. So numbers that multiply to give me 16 that add together to give me 8. Now here's what's going to make these special is when you're doing these, 4 times 4 is going to give me 16. I need a positive 8, so both of these are going to be positive 4. So you're getting the same number on the same side of your X. So I'd put my a value, which in this case is 1, down in the denominator, and read from the bottom up. So now if I go to read this answer, my answer here would be x plus 4 times x plus 4. Now, because I can rewrite it, or I'm writing that same thing, both set of parentheses are the same. Since both set of parentheses are the same, we are allowed to write this as, let me get my exponent, as x plus 4, the quantity squared. Just makes it shorter, and we don't have to write both parentheses. So in this case, again, if I go to the second example, sometimes that extra variable in there throws some people off, so I wanted to show you one of these with a y in there. So again, I'm going to find my numbers that multiply together to go on top. So 1 times 36, my 36 is going on top of my x. My negative 12 from my b value is going in the bottom of my x. Numbers that multiply together to give me 36 that add together give me negative 12. Well, 6 times 6 is 36. 6 plus 6 is positive 12. So if I make both of these negative, then it'll give me a negative 12. So now I'm going to divide by my a value, which is 1. Remember, I'm going to put that x because of the x squared. Now some of you are going, okay, what about that y? I see that y in the problem. Do you see the y squared with a 36? And remember, we got that 6 and 6 from the 36. So I'm going to put that extra variable there when it's y squared at the end. I'm going to put that y on the top. And again, now I'm going to read, simplify your fractions. Can't do that in this case. So now I'm going to read my answer from the bottom up. So in this case, I would have 1x, or just x minus 6y. My second one is the same thing, x minus 6y. So if I wanted to, we could write that as x minus 6y, the quantity squared. Okay. So here's where I would, again, take a minute, try this one, try that last one on this page, see if you can get it, pause the video, come back in just a minute and check it when you're done. Okay, in this case, if I try this one to solve it, I'm going to find my a times my c, so 9 times 100. It's a huge number, 900. So in this case then I want to get 60. And these are, you'll notice like here guys, 16, I took the square root of 16 also to get 4 and 4. Square root of 36 is 6 and 6. So really you could try to type in your calculator square root of 4 or 900. Square root of 900 is 30. And 30 plus 30 is 60. So it does work by taking those square roots only when you can also notice the first and the last are perfect square numbers. 16 and 1 are perfect squares. If we go back up here, 1 and 36 are perfect squares. Okay, so now I'm going to divide these by my a value. So I'm going to divide these by my 9. Put my y, your variable, in the bottom. And now simplify your fractions. So if I go to simplify this, 3 goes into both of those. So I'd get a 10 over 3y. And I would get the same thing over here. 3 goes into both of these, so I'd get a 10 on the top, and I'd get a 3y on the bottom. So now if I go to write my answer to this one should be 3y plus 10, 3y plus 10, which again I can write as 3y plus 10, that whole thing squared, because they're both exactly the same. And so I can write it just combinedly as squared. Okay. The last slide of these notes, these are really short and quick notes, is again, what about that idea of solving these? Okay. I kind of just alluded to this on the other side, and I would expect most of you just use the X method. But the other thing I should have shown you, and so you'll notice, is if I pay attention to these first two being perfect squares, you could do it kind of that same way we did that first one on the first slide when there's only 2. In this case, if I take that square root of that first term, so the square root of 4x would give me 2x. And so I'd have a 2x in both of those. That square root of 9 is 3. And then because this is a positive there in the middle, if it was a negative, I would put negative signs, but because that first sign is positive, what I'm going to do is these are both going to be positive. And so I have 2x plus 3 times 2x plus 3. Now, this is set equal to 0 because this one was a solve one. But you'll notice both of these are the same thing. So really, I just have to take one of them, set it equal to 0, and solve that, because if I did the other one, I'm going to get the exact same thing. So in this case, I'm subtracting 3. So here then I would have 2x equals negative 3. I would divide both sides by 2. And that's going to give me that x is equal to negative 3 over 2. And there's my answer. Last one, you'll notice only has 2 terms. So again, I can do the same thing we did on that first slide, is that the 25, square root of 25x squared would be 5x. 5x. And then square root of 1. It's one that people have a hard time with, but the square root of 1 really is just 1, because 1 times 1 is 1. And then because it's negative, remember that I'm going to have one of these as my positive, and I have the other one as a negative. Now, in this case, unlike the one above, I cannot just set one of them equal to 0 because they are not identical to each other. And so in this case, what I'm going to have to do is I'm going to have to do 5x plus 1 equals 0. Then I'll have to do 5x minus 1 is equal to 0. And now I can solve both of those. So on this one, first one, subtract 1. So here I would get 5x equals negative 1. And here I would add 1. So you get 5x equals positive 1. Divide both of these by 5. Divide this side, this one by 5 as well. And so I would get 2 different answers. I get x equals negative 1/5, but I also get x equals positive 1/5. And there's my answers. Right? So these are special ones. These actually do go pretty quick because they are all about the square roots, the perfect square roots. And so these can go pretty fast if you remember the rules that the 3 ones are going to be identical, have the same sign. The 2 ones that are special are going to be opposite signs. Okay. If you have any questions, again, please ask me. I'd gladly go over it or explain it a different way for you. Thanks.